Good afternoon. My name is Jamal Abdalla. I am Professor of Civil Engineering at the American University of Sharjah. With me is Professor Rami Hawileh. He's also a Professor of Civil Engineering at the American University of Sharjah. And we have Engineer Abu Bakr Mohamed, who is formerly a master's student who completed his master thesis under our supervision. This presentation is based on his thesis. Well, the title of the presentation, Flexural Strengthening of Reinforced Concrete Beams with Externally Bonded Hybrid Systems. The outline of the presentation as shown, I will start with introduction, then talk about research objectives and milestones, research background and literature review, experimental program, experimental results, conclusions and references. Strengthening of structural members has been one of the forefront topics for many researchers and practitioners in structural engineering, and this is due to many things, because building age and the building age properties, mechanical properties changes, and therefore they need to be strengthened. Building functions change also over time, and therefore the load that's supposed to support may increase, and therefore members need to be strengthened. Codes may change also, and therefore new requirements may come and need to be satisfied, and so forth. So all these factors make that a strengthening of structural members is necessary, and basically to improve the capacity of the section, or sometimes regain some of the strength that's been lost. And the picture here shows an example of typical strengthening of slabs, walls, columns, and beams. What is strengthening? Well, one of the most widely used mechanism or system for strengthening is what we call externally bonded reinforcement, and or EBR. This EBR, basically, you have an existing reinforced concrete members shown here in black. You need to strengthen this, increasing the flexural capacity of it, for example. That means we need to have more tension be resisted by the new member that will be externally bonded, and we need to have a bonding material like epoxy adhesive to bond it. And this is a typical mechanism of externally bonded reinforcement that we see in practice. Okay, what is the main objective of this research? Well, the main objective is to explore the effectiveness of using aluminum alloy, carbon fiber reinforced polymer, galvanized steel mesh as hybrid combination, and this will be introduced as a new external bonding reinforcement material for improving the flexural performance of reinforced concrete members. Okay. Well, the milestones basically is determining the mechanical properties of this hybrid combination of ACFRP and GSM. Evaluate the flexural performance of reinforced concrete beams externally bonded with such hybrid combination of newly introduced EBR. Assess the viability of adopting this new combination as a new externally bonded reinforcement material with its new advantage. A little bit of background, the literature. Well, as I mentioned, CFRP has been used extensively, and it has been very efficient material for strengthening structural members. Okay? The only problem they have is they are not ductile, and they have issues with performance when we have high elevated temperatures and so forth. Okay, and studies have shown that the CFRP can increase the flexural strength of a member of something close to 200%. Well, recently there is a steel mesh, or called galvanized steel mesh, which has been introduced also as a strengthening material, and this increases the ductility because it's more ductile than CFRP, and can increase the strength of up to 300%. However, also since this is steel, and as though it's galvanized, steel is susceptible to corrosion and other environmental problems that it may face. Um, some investigators try to use a hybrid combination of existing fiber reinforced polymers like carbon fiber with glass fiber to improve the ductility of the carbon fiber. And also there are good results came out of that. The strengths get reduced a little bit, but the ductility get improved. Okay, recently aluminum alloys has been surfaced as one of the potential externally bonded reinforcement that can be used due to many advantages. Well, first, it has a lightweight than steel. It doesn't corrode, or it has more corrosion resistance than steel. It has, to some extent, high strengths because of the new alloys that in the market. So these characteristics make a possible material that we can use. However, in this study, we are not using aluminum by itself because aluminum, in terms of strength, is not as strong as steel mesh, or it's not as strong as CFRP, but it's more ductile than them. So having a hybrid combination of aluminum alloy and CFRP, or aluminum alloy or GSM, it will compromise a little bit of the strength, but the ductility is expected to be improved. And this is basically what this study is all about. Okay, we designed an experimental program. I will go through the material properties, the specimen preparation and testing, the total test matrix, and then we show some of the material characteristics from the hybrid system that's been developed, and then the application of these hybrid systems, hybrid materials into strengthening of beams in flexure, and see how their performance will be. So it's the save of time. I'll go quickly over this. Here are the different materials and their properties: the concrete, the steel rebars, the carbon fiber reinforced polymers, and the galvanized steel mesh, and the aluminum, showing their yield strength, tensile strength, and modulus of elasticity. Okay, the experimental program that we carried out, although I'm not showing everything in this presentation, but basically we have a control member beam which is unreinforced, and then we have member which is reinforced only with carbon fiber, and then other members which is reinforced with hybrid combination of aluminum alloy and GSM, or aluminum alloy and CFRP. Preparation material here is as we said, we need to see the characteristics of the material before we use it, which is here are the samples, or the component samples of aluminum to the left, CFRP, and then the steel mesh with different intensities, from high one with high intensity to the one which is low one. Roughly the properties of the concrete, which is actually measured at the lab, and other, some of them is provided by the manufacturer, and the material is used here, which is shown the FRP layers, the width of them and the length, and then we have other things. The material has been, the surface has been roughened in order to increase the bond, and we use 2 No. 16. A typical shape of the beam will look something like this. The top cross section is without reinforcement, without external bonded reinforcement. The lower one is with. Sorry for that. Then we move on to the preparation of the specimen. Here is how the beam was prepared in order for testing. And as we said, we have a control beam, and we have other beams which are reinforced with either hybrid combination or the CFRP. The component test for the hybrid combination of CFRP and aluminum shows this. We tested 3 samples, and you can see there the relationship. I mean, they're very close. Here is steel mesh with high density with aluminum alloy, and this is how the behavior of it. You can see that the effect of the aluminum is shown at the end here. Okay, a summary of these 6 specimens that have been tested as a hybrid combination of carbon sheets with aluminum or steel mesh with aluminum. That's what it shows, and the different failure modes of each of these is given. Okay. We use this one to strengthen beams, and this is the first beam, is a control beam, which is not unstrengthened. It's just a beam that's that strong has a large shear capacity but weak in flexure, so it failed by flexure, and you can see the ductility of the member here. The green one here, the deflection it shows is almost the same with the higher strength that we have over here. Here is a comparison of the increase that we have for the load. Here shows you the failure modes of the two members, which has been reinforced with the hybrid combination of aluminum and carbon fiber or aluminum and steel mesh. One of them failed here by debonding, one to the left, and the other one failed by delamination, which shown here. Well, in conclusion, we can say that the hybrid component laminates that combined aluminum alloy and carbon fiber reinforced polymer and aluminum alloy with galvanized steel mesh showed the ductile behavior with elongation enhancement compared to each of these material used separately, the CFRP or the GSM. So obviously, combining them with aluminum improve in their ductility and therefore influence the overall ductility of the members that will be strengthened in these. The second point is the experimental results showed that the beams strengthened with proposed hybrid system of this provided improved flexural capacity, and ductility values has been improved in these members. Okay, so these results are promising and actually encourage us to investigate further, which is not shown here, but we did more investigation of combining these, or maybe combining even three elements together to see their effects and how they improve on the flexural capacity of the member. These are references that have been used, and end of my presentation, and I will be ready to answer all questions.